Good afternoon, everyone. My name is Hugh Downs, and welcome to Compliance Future Proofing, Planning for Tomorrow, hosted by ASR. But before we get into that, I want to again thank the MTI Group, Daryl Wilson, Jonathan Chia, and Campbell Houston for presenting Examining How COVID has Forced the Industry to Adjust their Response to Media, Crews, Families, Concerned Public during an incident. Now I want to welcome Peter Giannopoulos from ASR, Valerie Cannon from Ocean Guardian, Nick Conforto at CR Ocean, Julian Gately, and Thomas Auslus to discuss compliance, future-proofing, planning for tomorrow. And remember, tonight at 6 o'clock, we have karaoke. Take it away, Peter.
Thank you very much, sir. I appreciate it. And thanks everyone for joining us on a gray Monday. Thanks to everyone at Shipping Insight, Carlene and your team for being such innovators and putting this all together. We appreciate it. We have an interesting workshop today. I have actually a PowerPoint presentation that I'd like to share with everyone. Including everyone out there watching us. So as we know, this has been a unique time, new time for our business with the compliance with the regulations that we've all faced. We realize that, you know, the future also, as we know, is going to bring new challenges. And this workshop is kind of about that, about how to be ready for those new challenges, how to use the equipment and the technologies that exist now, how to improve on it so that in the future, ships can still remain compliant. Next slide, please. So a little background on me, who am I, who my company is. We are American Ship Repair. Next year, God willing, we'll be celebrating our 70th year in business. We're a solution provider now with we basically evolved, staying in the aspirin business and not in the headache business. We've have an international portfolio of principals that we represent in the scrubber, ballast water, MGO chiller, and shipyard business. Next slide, please. So today we're going to be talking to a number of different experts in their fields. First, we're going to start with Nick Conforto, who, again, the technology that Nick is going to be talking about and has been serving the industry with is not new technology to Nick or to the land-based business, but they've marinized it at CROE and made it applicable and made it a solution for the marine industry. And Nick is also going to talk to us a little bit about what else is important about scrubbers besides now most of us have gotten past the 2020.5 challenge, but what else is, you know, what are the other benefits of having a scrubber? Which moves us to the second, which is Oberlin, again, a company with many, many years of service to land-based industry and has applied that in terms of the wash water purification for closed scrubbers. As we know, open loop scrubber wash water discharge is not detrimental, but still a lot of port states have concerns about it. And so Tom will be able to talk to us a little bit about that. Valerie Cannon from Total Marine Solutions has a product called Ocean Guardian. Total Marine Solutions, many of you know, is run by, actually, full disclosure, a very good friend of mine, Alex Anagnostis. And they have a system which allows you, again, I studied some advanced math. I'm a degreed engineer, but sometimes the matrix of these regulations is a lot to understand. And Ocean Guardian allows you to understand what the rules are, where you are in real time. And it's just a very interesting system. Michali Avellano is up late in Athens waiting to do this. And as we know, the engines are burning fuels now that they were just not designed to burn. And what Michali's company does is allows customers that are burning now MGO or fuels that are a lot about MGO more reliably and successfully. Finally, Bud from Herbert Engineering, our friends over there, Spencer and Eugene von Reinbach and Bud's company. He's going to talk to us about one thing that we've learned, and our company has been involved not only with the equipment selection, but also with the installation, the whole planning of it. And what we've found is that all these projects are only as good as the weak link. You could have a great piece of equipment, a great shipyard, a great team, but if the engineering isn't done right from the beginning, you got a problem that eventually is gonna show itself. So Bud will talk to us about that. And with that, I'm 1 minute off, 1 minute late. I pass it over to Nick Conforto. Thanks, everybody. Thanks, everybody. Nick?
I can't hear what you're saying.
Unmute yourself, Nick.
Yes, something sounds weird. Not sure where that sound is coming from. Do you hear it as well?
Yes, I do.
Okay, I'm not sure who's got the problem with the mic. I think it was Tom. He just logged off.
It's the compliance devil. It's the compliance devil.
Yes, it is. Well, thank you for inviting me to speak here for today. Thanks to Colleen, Carleen, and to you, Peter. I will go through my presentation quickly. I know we only have a few minutes each. I represent Sierra Ocean Engineering. We do scrubbing systems for ships and also for land-based. But primarily our discussion here is about ships. You see there one of the pictures of our systems going into a ferry. The company is a 100-year-old. The next slide. Yep, company is a 100-year-old company based in New Jersey. We started in manufacturing back in the early 1900s. Since then, we've entered the scrubber market in the 1950s. And when the issue of ship scrubbers started to develop, the IMO discussions, we decided to also enter the marine market, bringing our technologies into that. We've been doing this now for quite a few years, and we have installed several units. The next slide. The systems we've installed on ships are about 158 of them, plus or minus. There may be a couple more that we have done, but I'm not sure. But you can see there from this list that they go pretty much throughout the gamut of different type of vessels: bulk carriers, container ships, LPG carriers, tankers, ro-packs, ferries, cruise ships, and even some heavy lift vessels. Next slide. Our units are all metallic, and we have I-type, U-type, and the new L-type designs. We do open loop, closed loop, and hybrid systems. So whatever ship needs, we have it available. They can replace the silencer, or they can be installed in parallel to the silencer. It will be up to the customer. Our designs are made to take the dry run temperature, so either way will work fine for us. They're designed for the high temperature. Looking at the future, we're looking at some of the alternatives of what may be coming down the line for scrubbing systems. One item we're looking at is particulates control. Our systems reduce particulates, but I think at some point soon we'll be seeing some PM 2.5 regulations. So our systems are looking at developing the PM 2.5. The sound is still back. PM 2.5 and black carbon emissions. Additionally to that, if the issue of open loop discharge becomes more widely a problem, then at some point customers will ship to closed loop systems. So what we've done is we've developed a relationship with Oberlin, where we are now offering exclusively for the industry the Oberlin systems for application on ships to clean the wash water from the scrubbers. Oberlin is going to do a presentation next, and you'll see some of the information which is very interesting on that system. Next slide. The benefits of scrubbers are quite wide in the terms of pollution. You're looking at reduction of sulfur emissions, both SO2 and SO3. You're looking at reduction of particulates in black carbon. Also, the CO2 footprint of using high sulfur fuel versus low sulfur fuels is much lower. So you could see a benefit of in a neighborhood of about 10 to 14% reduction in CO2 if a ship uses heavy fuel with scrubber versus light fuel without a scrubber. So there is a CO2 benefit, which is also a requirement right now for the shipping companies. And of course, the cost is the advantage. We still, even at today's low prices, you still have a cost advantage if you already installed scrubbers. Next slide. In terms of SO2, you can see that the scrubbers can achieve near zero emission of SO2, which is much lower SO2 emissions than even MGO. So when we're talking about 0.1 fuels for the ECA, you can achieve lower than that in an ECA if you use heavy fuel and you use scrubbers. Next slide. Looking at particulates, the issue is the fines. The large particulates are removed now by the scrubbers. But when you're looking at the fines, that is where we are driving our development at this time. We're looking at developing systems that can remove PM 2.5 particulates, which also includes black carbon. Now you're hearing about black carbon in the Antarctic and the North Pole, but at some point it will be an issue of health, where by reducing the PM 2.5, you will have saved significant amount of problems to respiratory disease, lung disease, cardiovascular, and other possible cancers. And the scrubber will be able to do that. When looking then at PM, at the particulates, you're looking at the black carbon, which is this. This is the picture that tells the whole story there. You see the 3 slides above are MGO used in a ship. 3 slides below are heavy fuel and scrubbers. These are taken at the stack. So as you can see, even though MGO sounds like a great idea, it's really not. Next slide. And I'm going to let Tom from Oberlin discuss the systems, but we do offer 2 systems, one for pumpable sludge and the other for dry sludge. The Oberlin has the dry sludge and is the most efficient system in the industry. So we've now connected with both of those to offer to our clients. Thank you very much. I'll pass that on now to Tom. Thanks. You're on mute, Tom.
Tom, I think you're the devil.
Yep.
You're the compliant devil. Nick,
Can
thank
you
you
use
very
a phone? Can you use some other way of connecting?
Tom, if you go to the lower left-hand corner of your screen, there's a mute button. Corner of your screen, there's a mute button. I'm off mute now. Can everyone hear me?
I cannot hear him. It's just a weird sound.
Yeah, me too.
So nobody can hear me now.
We can hear you.
Yes, I can hear you. I can't hear him.
Oh, okay. Okay, so next is Valerie. We're going to move on to Valerie. Valerie, can you unmute yourself?
Yes. Excuse me. Yes, I am
So
unmuted. Can you all hear me okay?
Can we put up?
Great. Good afternoon, good evening, good morning, if the case may be, everyone. Thank you again, Peter and Carlene, again for the opportunity for us to speak with you today. As Peter said, I work for Total Marine Solutions, a company that for the past 20 years has provided equipment and support to ships regarding regulated environmental discharges. Because of the relationships that we build with our clients, we're often included in conversations regarding how to manage environmental discharges and the related regulations. A particular issue often discussed is the uncertainty in knowing if the environmental guidance they have is up to date. Slide, please. So I know you all know that navigating environmental compliance in real time is a very serious challenge. For many, the task of managing environmental compliance is just one of many hats that they wear. You're all well aware that environmental regulations are many, complicated, difficult to interpret, and the trend is continuing to head towards more regulatory oversight. This makes it very difficult for operators to know what they can do and where. They may find themselves sailing into unfamiliar seas with no knowledge of what conditions for discharging a particular waste stream might be. And so accidental, non-compliant discharges, unfortunately, do still occur. Next slide. Let's take the Great Barrier Reef as an example. Operators making the passage through there for the first time may not be aware of the boundaries or what the discharge guidelines might be. They may rely on the pilot or the local agent for information, but these roles have different responsibilities than environmental awareness, such as the critical importance of the safety of the vessel. By not having ready access to local specific regulatory information, or by misinterpreting the information that they're given on short notice, mistakes obviously get made. And it isn't always the companies who have to absorb the fines. In some cases, the chiefs and the captains also get fined and potentially imprisoned. Slide. The Indonesian and Bahamian archipelagic baselines can also be extremely challenging. If a ship is relying on word-of-mouth information from another vessel or a spreadsheet that maybe they've had on board for a while, there's no way to verify that information on the fly. For years, and maybe some still do, it was believed that there were donut holes in the Bahamian baseline where they were permitted to discharge, but this is not the case. A number of vessels have been found to have accidentally discharged a variety of wastes inside these baselines due to this misinterpretation. Slide, please. And how often do these regulations change? We know it isn't the same for all countries, regions, and ports. Some change infrequently, and others seem to change every day. Port tariffs in the United States are often reviewed annually, but any changes may not be highlighted. Or if the language in that tariff doesn't change over time, how does that language then apply as new issues and discharges come into play? Ballast water is a great example. This is a discharge that's relatively new to being regulated, and its inclusion in older language may not be fully understood. As an example, the Port Everglades port tariff does not allow for ballast water discharges due to language that has been a part of that tariff for many years. And as an added side, while Port Everglades says no to ballast water discharges, Miami, just a few miles down the coast, allows it. So we have two ports in US waters in the same region with opposite guidance, and this just adds to the compliance challenge. Slide, please. California is also known to be very challenging for ships transiting there. They extend their guidance out to 24 nautical miles, and it's often more stringent than what US national regulations state. Particularly for vessel operators who have not transited here in the past, it is essential that they have the most up-to-date information prior to heading into California waters and ports. Slide, please. Probably the best recent example of how difficult trying to manage environmental compliance in real time relates to wash water discharges from open loop EGCS. It seems almost daily that more countries and ports are banning the use of open loop EGCS or the discharges of its wash water. Currently, we have tracked more than 300 ports where open loop EGCS cannot be used or the wash water cannot be discharged. Some familiar examples are China and Taiwan, but maybe less known might be the ports in the UK. While the UK has stated that they will not ban this discharge on a national level, we continue to find ports that have put out recent guidance stating they're not allowing the discharge of open loop EGCS wash water. And then there's the issue of regulations changing from month to month. This can have real implications for ship operations. Argentina announced in early August that open loop EGCS wash water would not be permitted to be discharged, but then this was quickly suspended in the course of a few days in late September. The minute one of these guides or the new regulations goes into effect, the email on the ship from last year, in the binder at the back of the bridge, or the spreadsheet that was updated 6 months ago is no longer valid. Slide, please. So staying abreast of these changes is challenging to say the least. Email communications from agents are not always correct. Binders of guidance can very quickly be outdated and spreadsheets can't be secured against unauthorized changes. Digital solutions, system integrations, and collaboration are essential to managing the vast number of environmental regulations in real time and to help take the guesswork out of environmental compliance. Navigating this compliance in real time and space requires solutions that are regularly updated with that information quickly being sent out to the vessels. Slide, please. Ocean Guardian is just such a system. It is a digital database containing currently more than 4,400 maritime environmental regulations that are geotagged so that vessels can see what they can and can't do at a glance. It's 2020, and we really can do better than spreadsheets and emails. Solutions like Ocean Guardian bring all of this information into one place where it can be more easily and transparently managed. We have a dedicated team of maritime professionals at Total Marine Solutions who work to input and regularly update these regulations. We also have a global network of contacts assisting in making sure we have the most up-to-date information. When a new regulation or guide is found, it can be uploaded, vetted by our third-party maritime law firm, and deployed out to our vessels very quickly. Slide, please. Ships can quickly understand what MARPOL baseline they're in and the regulations that apply to that location. It can be used to plan their environmental operations ahead of time via the built-in environmental ops tool. ECDIS files can be imported into Ocean Guardian, displaying the environmental regulatory requirements for that route. Shoreside managers can also quickly see what regulations apply for their vessels in the Ocean Guardian administration portal. In the Fleet Ops module, we pull in an AIS feed for the ships in their fleet, which assists in expediting shoreside support. Company policies can be loaded into the Ocean Guardian database, further simplifying getting updated information out to the vessels. Slide, please. Ocean Guardian has also been integrated into leading navigation software, such as that provided by Navtor, as an overlay to again help streamline the planning process. This integration offers efficiencies of time and accuracy of planning. Simplifying compliance and navigating regulatory changes in real time means solid decision support that can help prevent accidental non-compliant discharges. Slide, please. Thank you very much.
Thank you, Val. Greatly appreciate that. Great job. Thank you. So now I'm not sure where we are on Tom, but why don't we move on to the next presentation while Tom works that out. Next is Mihaly. Mihaly, are you with us? I can see you, Mihaly.
Hello. Can everybody hear me?
Yes, we can hear you. Okay, can we
that's great.
Mihaly's, and you don't sound like
great. Let's start with our presentations. Okay, first of all, I would like to thank the SHIPPINGInsight for the hospitality and state my admiration for this wonderful and very interesting virtual conference. All presentations I've heard so far are very interesting. It's important at these challenging times that we are all experiencing to remain at high alert and find new ways such as this one to communicate. So I want to seize this great opportunity and present you our company and by extension our products and solutions. Slide, please. At first, I would like to share some information regarding our company. Farad has been designing and manufacturing tubular heat exchangers and plate type heat exchangers for marine and industrial applications since 1979. Our company is based in Greece, employs more than 60 people, and has completed so far more than 25,000 successful installations. Slide, please. Now, I would like to mention a few significant milestones of our company over the years. In 2001, our company acquired its current factory. In 2015, we acquired the DNVGL approved manufacturer certificate. And this year, we added a new product, the plate heat exchangers, in our catalog. Last but not least, within 2021, our production capabilities will expand to a new area with a new state-of-the-art machinery. Slide, please. Through these 40 years of experience, we have acquired valuable knowledge and technical expertise in 5 different industries, such as marine, energy, food and beverage, refrigeration, and petrochemical industry. Slide, please. Farad's manufacturing process includes quality assurance and quality control. We have tight control of our manufacturing process and strict tracking of every raw material that enters our workshop. We only use top quality European Union materials and hold valid certificates. All our products are according to ASME code or any other national code, and also we are fully certified by Bureau Veritas and approved manufacturers by DNVGL and ABS. Slide, please. Now, what really, in my opinion, distinguishes us from the competition are the tailor-made solutions we provide to our clients for any possible demand. This flexibility is the result of the hard work and efforts of our R&D department. As we can see in the next slide, please. With high quality personnel and up-to-date software for thermal and mechanical design, we have the ability to prepare calculations for any possible heat transfer scenario and meet any technical challenge. Slide, please. Now I would like to present some of our most renowned products. Our company fabricates, as I said before, every type of tubular and plate type heat exchangers. As we can see in the next slide, here are some of our most famous products, such as box coolers, cargo condensers, freon condensers, steam condensers, many types of evaporators, gasketed plate heat exchangers, freshwater generators, any kind of air coolers, steam and electric heaters, and of course, one of our most popular products nowadays, due to the recent change in low sulfur emission regulations, the fuel chilling unit, for which I'm going to speak today. Slide, please. Now, in order to take a closer look at our chilling unit, I believe it's important to comprehend first the problem that it was designed to solve. As you already know, under the new global cap, ships will have to use fuel oil on board with a sulfur content of no more than the strict limits that are established. Therefore, the fuel oil systems on board require modifications. Ship's fuel oil injection system is not designed to use low sulfur fuel oil. Fuel oil injection components are going to be affected and deteriorated. Fuel viscosity, combustion quality, and lubrication are some of the operational challenges. Also, as we know, the MGO needs to be cooled down to 18 degrees Celsius in order to reach the required 3 centistrokes. Slide, please. Now, let's see the solution that Farad has to offer. We have designed a new all-in-one chilling unit ready for connection of fuel line and power supply. Our chilling unit standard design data are impressive. For an MGO inlet temperature of 50 degrees Celsius, our chilling unit can cool it down to 70 degrees Celsius. Farad chillers are designed to assist owners burn the new fuel requirements, including the blended fuel oils and MGO, in engines that are not designed to do that. Slide, please. Now let's take this closer look that I was mentioning before to our chilling unit. Farad chilling units guarantee trouble-free operation, easy and fast installation, endurance in heavy marine conditions, plug and play on fuel line and power supply, minimal footprint, easy maintenance. Also, our units are approved by all leading classification societies. They are designed for existing and new vessels and have a fully automated temperature control. Also, all of our chilling unit products are type approved by ABS. Next slide, please. What I didn't mention before in the milestone slide is that our company has been awarded the Technical Achievement Award by Lloyd's in 2018. And the reason was, of course, the chilling units that I am talking about right now. They draw the attention to their plug and play design and other features. And because of our more than 40 years presence in the demanding market of marine industry, in addition to the quality and technical excellence of this product, were the key elements of this outstanding success. We consider this prestigious award as a great recognition of our efforts and as an opportunity for further development. Next slide, please. Here are some of the main advantages of our chilling units. As I said before, the minimal footprint due to the sophisticated design. Also, there is a simple electric panel design with PLC for easy maintenance and operation. The units are suitable when main engine and generator engines have common fuel oil service systems. Also, the cooling system may be fresh water or seawater. We can tailor make any solution according to each vessel's specifications. And also, it's important to mention that our units have been installed in various sectors such as power plants, commercial ships, naval ships, and government vessels. Next slide, please. Now, except the chilling units that I am talking about right now, we have also developed the MGO product series which can be installed in the fuel oil service system. In case there is no space on board for a complete compact chilling unit, we can also offer standalone coolers. The optimized plate type and the cell and tube designs offer easy maintenance and significantly smaller footprint. However, the large heat exchange area is still guaranteed. Our cooler options include exciting features such as controlled temperature, even in small difference, less fouling due to higher turbulence, and easier installation with the need of only minor modifications. Especially our gasketed plate heat exchangers are a wide series of equipment which are suitable for all types of industries with multiple applications including heating, cooling, condensation, and evaporation. Next slide, please. Now I'm going to close this brief presentation by stating that Farad does business with companies all around the globe. We treat all stakeholders as essential partners. That's why more than 500 companies show us their trust, from shipyards and new building projects to power plants and oil refineries, and the most notable shipping companies. Next slide, please. Thank you all for your attention. I hope it was interesting for you as it was for me. Have a good evening, or should I say day, because as Peter said before, here it's almost midnight here in Greece. Thank you very much.
Thank you, Michali. Thank you. It was very interesting. We appreciate it. So I guess Tom is still, and we're ahead of schedule. This is really good, I guess. Tom is still trying to get on. So if we can please put up the Herbert presentation, and Bud, you're up.
Yes, you can hear me fine?
I can hear you 5 by 5.
Aye, sir. So thank you for this opportunity. I'm Bud Gately. I'm a Senior Associate Marine Engineer for managing the Houston office for Herbert Engineering. Here we will cover how effective detailed engineering ensures a successful retrofit of complex systems in existing assets. Next slide, please. So this was okay. I'll introduce Herbert Engineering. We are an employee-owned company based in California. We offer detailed turnkey engineering planning of retrofits of complex systems into existing assets using laser scanning and support services. We have offices around the planet, including San Francisco, Annapolis, Glasgow, Shanghai, and Houston. As more environmental regulations are being passed and enforced, owners are responsible for meeting environmental standards globally. If a faulty design is used and the vessel cannot meet the regulation requirements, the owners are fined, not the equipment manufacturer or the installer. This risk requires considerable thought in selecting a competent engineering design to ensure the system will work as required. Next slide, please. Goals with proper planning ahead of time. With proper planning ahead of time, the system design will be thought out and designed as required in 3D space. A suggested minimum 1-year planning before required installation date. The system will be built piece by piece in a virtual environment before installation to minimize the cost and risk to the owner. This eliminates unforeseen problems before they occur while the vessel is in the shipyard or in service. Next slide, please. The ship check is essential for locating equipment efficiently. Laser scanning for more congested engine room spaces obtains an exact 3D picture of the space where the system will be installed. New equipment can be placed in the 3D point cloud. Retrofitting a system with large piping tie-ins into a cramped engine room or pump room is challenging. As-built drawings are sometimes not available or incorrect. Number of ship checks are minimized through the use of laser scanning. The consideration must be given to hazardous spaces and hazardous cargoes, consideration for equipment operation and maintenance access. Piping sizes must be known to understand the scale. Detailed design provide installation planning for an owner to ensure a successful completion of the project. These principles are especially important for future-proofing technologies so that the owner can get a benefit of a quick adaptation later. Next slide, please. Here are two examples where 3D scanning was used to provide a detailed engineering design and prefabrication ahead of installation. The three photos on the left are laser scans and 3D models of an ATB bulker carrying coal, planning and installation of an EcoClor ballast water system enclosure on an existing raised platform on the starboard side of the notch. The 5 photos on the right are 3D modeling of a CR Ocean scrubber installation for a container ship. Take notice of the very tight clearances between the scrubber and the ship. The 3D point cloud helps with placing new equipment. Once placed, the scans and the models assist in the design of equipment foundations and pipe spools. It can be used for prefabrication of foundations, pipe spools, and new structures such as new superstructure, new deck houses before equipment arrives at the shipyard. Next slide, please. Ship structure and way of filter foundation can be modeled as required to ensure tie-in points are not on the side shell. New equipment locations can be shown to guarantee available space, available access and maintenance. Existing system tie-in points can be modeled in the existing piping. Obtaining a model of this accuracy without scanning would require a large amount of onboard time with a tape measure and possibly additional ship checks. Measuring the entire space to obtain an accurate picture is much easier with a laser scanner. Locating pipe supports is possible with this model once the design is finalized. Some existing equipment may need to be relocated in order to accommodate the new equipment. Next slide, please. Possible design issues. Integrating the existing automation and monitoring systems. We have things like valves, sensors, alarms, automated activation and shutdowns. The use of combined service equipment such as pumps and eductors. Using the correct materials. Some of the chemicals require exotic materials such as caustic soda, sulfuric acid, sodium hypochlorite, ammonia, urea, etc. Many plastics cannot handle the UV light and UV systems. The design of maximum flow rates. Ballast water filter might need to be oversized to account for the extra flow rate. For this extra flow, proper designed head loss calculations. Do the pumps have sufficient power to incur the additional pressure losses? Does the engine exhaust back pressure? Is it too much? Do the equipment manufacturer require fiber optic or Ethernet communication between components? If it's greater than 100 meters, it must use fiber optic. Ethernet cables installed next to existing power cables might in the tray. Will there be interference? This is very difficult to troubleshoot. There is no interference with the fiber optic. It's more expensive. It requires media converters installed to handle. Next slide, please. Electrical panels, where to place them, emergency stops, censoring equipment, alarms, interlocks. These are surprisingly difficult to place. Often, you can't squeeze breakers into existing distribution panels. Does the distribution panel require modification? Does it require shutdown during the shipyard period? You need to plan this accordingly. Sample points and probes. Do they need to be located near the discharge, along the seawater supply line, or in the engine exhaust? Material handling of hazardous chemicals, caustic soda, sulfuric acid, sodium hypochlorite, ammonia, urea. Crew may not normally handle these in the past, need to know how to handle them in the future. Crane access. Is there a shoreside crane that's needed for resupply? Or a new crane installed? Stability. Is a new inclining required? A deadweight survey and experiment or an inclining experiment may extend the yard period. Don't wait until the shipyard to find out that a new incline is needed. Firefighting. Does the new installation require new or modified firefighting capabilities? Documentation. Does a new electric load analysis is needed? Increased in dead weight, change in registered tonnage, updated fire control safety plans, updated general arrangement, updated capacity plan, a T&S booklet, updated loading computer. These are things that need to be considered. The takeaway is in-depth feasibility study and design work is invaluable. A quick feasibility study, be wary of a quick feasibility study. Simply can't plop a scrubber and new pumps in and say it fits. Pipe routing is important. Economics. Both the upfront and lost revenue from the yard period need to be considered. More engineering upfront to mitigate this risk. Material logistics are important, and the class and flag state type approvals are important. I ran across a situation where a type approval was expired and we had to scramble to find a new material. Laser scanning and 3D modeling ensures the success of the project. Recall earlier the picture of the scrubber fit up on the container ship. The 3D scanning and modeling done wrong can be costly. Next slide. Thank you. I'm sorry. Next slide. That was the end. Well, thank you. If there are any questions, I'll throw it back to Peter.
Well, thank you very much, Bud. I appreciate it. I don't see any questions from anybody of the viewers. We're waiting for Tom to connect. He's trying a different way so he won't sound like Darth Vader of regulations. In the meantime, just wanted to say thanks again to everybody here. And I don't know if does anybody here have any questions for any of the presenters that have already, your fellow presenters? No? Okay.
Do you want me to do the presentation for Tom?
Oh, sure.
That's a possibility, I guess. We could probably just go through it that way.
Yeah.
Okay.
Do you have it handy, Nick?
Yes. Yes.
Okay.
Okay, let me try something here. Okay. Yeah, you have it there. Good. Okay, so bear with me, and I'll try to do my best. Yeah. So what Oberlin is a company from Wisconsin, and they do water treatment for various industries. And recently, we've been working with them to by we I mean the CR Ocean Engineering, to provide the water treatment for closed loop and hybrid systems to the shipping industry. The system has been installed on some vessels already with very good performance, and we are now the exclusive supplier to the shipping for this type of system. Going on, next slide. And looking to see what he had on this, is looking at the basic upper loop system and the amount of water, which is very large, that is being disposed of at sea, because the upper loop system is a once-through system. Once you have the scrubbing, then all the water goes back out. And most of it is what's in that water is some of the soot, of course, and primarily it's sodium sulfates, which is the result of the reaction with the sulfur. Next slide. The next slide is what you then, in comparison, what you will see with the closed loop or hybrid system, and the much lower amount of water. So as in open loop, you saw about 2,000 to 3,000 meter cube per hour for this fictitious installation that he's using as an example. In closed loop, you only see about 2.5 to 5 meter cube per hour. So the difference is incredible difference between open loop and closed loop. And that's also why in open loop, there is no water treatment system, because if you try to do a water treatment system for open loop system, it would be very large. And most ships will not have the space for that. So what vessels are doing, they either go closed loop if they want to treat the water, or they go to hybrid where they can operate open loop at sea and closed loop, say in port, if the ports continue to make it difficult for open loop. So you will have a much smaller amount of water. However, the amount of water is small, but the pollutants are the same. So it's much more concentrated. And that is also a reason you definitely need water treatment, because now you have a very concentrated stream and you need to treat that before it goes out to the sea. Next slide. The Oberlin system is a dry disposal of sludge. So what comes out of a water treatment for ships, you have sludge and you have water. The water is the sulfates, which is now proven by all the studies that there is nothing wrong with that. It can go to sea without any effect. However, now you also have the solids, which are concentrated, so they have to be removed. And the solids are typically removed by a typical water treatment system in a slurry form, which is a very dilute form. So it's a very large amount of solids. Versus on a Oberlin system, they're concentrated in a dry form, so you don't have all the water in there, so it makes less volume. And because there's less volume, you spend less on disposal costs. And this example that he's giving you, you're looking at $14,000 per 24-hour period in a very untreated disposal, that's the sludge, versus about $10 for 24-hour period in a dry form, because there's a very small amount of solids. So when you're treating even the concentrated soot, it's not a large volume. The soot from the ship is very small amount, but it looks very dirty when it's in water because it makes the water black. So you have to separate that. So in a dry form, when you only have the solids, it's a very small amount, and therefore the cost of disposal is very small. Next slide. What he's showing here, you see the sludge from Oberlin system. You see that on the left top corner, and also below that in the bottom. and you see how the sludge is very dry. There's very little water and moisture in it, and reduces the volume by an incredible amount. On the right side, you see the ship installation that they have. And that's what the system looks like on a vessel. Next slide. So our teaming with them is that they will sell their system through CR Ocean Engineering to all the vessels that require it, whether it be our own scrubber or any other scrubber. So we will be selling this to our competitors, even our scrubber competitors, if they choose to use this, because what we want to do is offer this technology to everyone, because it's such an advanced technology that I think it's good for the whole industry. And if you look at the next slide, please. The reason for this interest from us with Oberlin, it's right there in that picture on the left top corner of the slide here. What you see in black is the water from a closed loop system. And after that, in clean water is after the Oberlin system. So you can make black water completely clean using the Oberlin system. And as a result of that, try to avoid some of the negatives that have been associated with scrubber discharge. So that is our interest and why we like this system so much. Besides the fact that what you see just below that picture, you see the sludge in a dry form, which will save a tremendous amount of money to the customer that now has to dispose of many tons of wet sludge, because most of it is water. It's like 90% water, disposing it as a sludge versus only disposing the solids, which is a small amount, and saving quite a lot of money each day. And hopefully Tom will not object to my presentation of his slides. Thank you very much.
Okay. Thank you, Nick. Can you hear me?
Yes.
Tom, are you with us?
I am with you, and Nick did a great job through the slides, better than I would have.
Well, never better, Tom. Never better than you. But
well, I'll tell you.
I pulled it through in an emergency.
I really messed things up for you guys. I apologize. So I don't know what
Not
was
at
going
all.
on.
Not at all. Actually, your Darth Vader voice, I think, added a little spice to our presentation.
Oh, is that right? That's what it sounded like.
You sounded
earlier?
like the
Yes,
the ghost
like
of compliance past or future.
Oh, on a bad day. Oh boy.
Yeah.
Zoom and me don't get along. It seems like all the other platforms work great, but there always seems to be some issues. But I apologize for missing everything there. But
no, not at all. Not at all. Not to worry. Not to worry. We managed to get through, and I just Nick touched on it. I actually wanted to just mention the sludge disposal costs that you mentioned, which Nick and Tom both. That also depends very much on where you are, because those sludge could get very, very expensive. And one of the things that's kind of similar with CROE and with Oberlin is, again, as I mentioned, they're both people that have long histories on land-based. As I said earlier, a lot of the technologies that are now being applied for the compliances that we need, regulation compliance that we need in this, this atmosphere now, are not new technologies, but are new to our business, our shipping business. In fact, Oberlin, we originally got contacted by a classmate of mine from college that said, hey, do you know what anybody said within their company? They said, does anybody know anybody from shipping? And my classmate was like, yeah, I know a guy. I mean, the shipping industry is, a lot of people are so unfamiliar with it, even though it's so important, and it's certainly important to us here, but important to the world economy. But a lot of people are unfamiliar with it. And so it's great that both CROE, both of those companies have this long history and can apply that expertise to what our shipping industry needs now. So we have, compliance people in Nick and in Tom and in Michali. We have Val to keep track of all of it. We have Bud to plan it and make sure that it's executed properly. So I think we have it pretty much covered in this little workshop here today. Does anybody have any further comments?
I have a question to Tom, if I may.
Sure.
Please.
So my past, before I was with Herbert, I had been with Transocean for 11, 12 years in the oil and gas offshore drilling. And one of the biggest problems with offshore drilling is handling mud waste, drilling mud waste.
Drilling mud, sure.
And have you considered another possible market for solid separation? Because what happens with drilling mud waste is that they pump it to an OSV for disposal ashore, and it equates to about $100,000 a month in waste disposal. And one of the things that I was tasked with and didn't completely solve was, how can we reduce that amount going ashore? So has this been something that you thought of, or something that you would
let me say,
looking into?
We're probably going back a few years. We had I think we had a pilot unit on an offshore rig in the Gulf. I'm not sure it worked. I have to go back into the archives or so and see what happened. There was also land-based drilling muds too that we tested on, and they worked very well. But any of those all of those projects never really went anywhere, and I have to find out why. But we're familiar with that, and we were looking at it, and there seemed to be a lot of excitement replacing large filter presses, and I'm trying to think what the other, the hauling costs. There was a group called Setco that was involved. They have mineral clays or so. I think they were, we had to add like a clay to it, I think, or so, to get it to settle out very, settled out or so.
Drilling muds don't settle so well because they're actually engineered on board the rig not to settle.
Yeah, exactly.
Well, thank you, Bud.
That's
thank
right.
you for that. And we have a question.
I could hunt it down and give you information later or so on that.
We also have a question from one of the folks, viewers out there. Actually, it's from Alex from TMS, who's asking, is there a deadline for owners from a regulatory standpoint, is there a deadline for owner operators to complete their EGCS installations? So that would probably be a question for our scrubber expert, Mr. Conforto.
No, there is no specific requirement for it. The requirement is already passed, which was January 1st, 2020. But that was for fuel switch. And the installations are really at a specific owner's preference, because now it's just an economics evaluation whether they install scrubbers or not. And
assuming, that assumes that they can reliably burn MGO. I guess it depends on whether
yes.
Michali or you, or how they're managing the 2020, right?
They will have to burn MGO or the low sulfur heavy fuel that's available.
Right.
So either one, but they have to do something which they cannot operate on heavy fuel without a scrubber.
Right. But Michali, I have a question relative to that. Even if it's like the low sulfur heavy, there's still a big element of MGO in it, typically. Isn't that right? Michali?
Yes, that's correct.
Okay. Okay, understood. All right, folks. Well, that brings us to 5 p.m. and the conclusion of our workshop. Thank you all for joining us. Thank you all the viewers out there for joining us. And thanks to Carlene again and to Shipping Insight for allowing us to have this workshop. And we look forward, please send in your questions if you have, or visit our booth. We have our booth together with CROE, and we welcome any questions or meeting requests you may have. Thanks very much, everybody, and have a good evening.